All right, so last week we started our 2.3 notes. We've had a lot of little hiccups along the way as far as life. But last week we did 2.3a, where we talked about quadratic functions and their zeros. And we talked about the vertical stretch and compression and what they look like, and then identifying the minimum and the maximum vertices. And we talked about the vertex formula, so how to find H and how to find K. This is really useful, especially if you're not really good at working with fractions. Does that make sense? Excuse me. So then we did an example of finding H and K using the vertex formula and then writing it in vertex form. Then we talked about vertex and axis of symmetry and how you also can use the vertex rule, such as substituting in once you find H, substituting in to find K, and how the parabola, the importance of your A. If A is positive, you have a happy parabola. If A is negative, you have a sad parabola. So then we worked another example, and I showed you how an example of why you may want to remember the K formula. Because look here, when we were solving for K, imagine substituting in 3/4 and evaluating that, right? So imagine substituting this in and finding all of that. Does that look pretty? No, it doesn't. Especially if you're not strong with fractions, you're like, ooh, never mind, right? And so just be mindful of that when we're doing it, okay? And then you have your K, whereas K, as long as you have A, C, and B, you're just plugging in and just multiplying, subtracting, and dividing. And it's going to give you your reduced fraction already, okay? So that's why reminding you how to find K. All right, we're here today at 2.3b part, which is example 3. Are we all caught up? Okay, the objective here should say objective 3, graph a quadratic function using its vertex, axis, and intercept. All right, here we go. So I was a very kind teacher and I typed all the steps out for you so you don't have to write them. All right, so we're going to go through these steps together. And these are going to be the 6 steps that we follow because guess what? You're the calculator, okay? This is another non-calculator section. You are the calculator, okay? If you use any calculator, it will just be the small handheld calculator. But here we go. So the steps that we follow is the first thing we're going to determine where the parabola opens up, which means that A is positive, greater than 0. That's a U, a real U, not a parabola. And then, or down if A is negative, okay? So when we're referring to A, remember we're talking about Y equals AX squared plus BX plus C, okay? Then you're going to determine the vertex. So you're going to find your H and your K. Remember, you can always use the vertex formula. So however you choose to determine the vertex is up to you. Next, you're going to determine your axis of symmetry and graph that. So your axis of symmetry is X equals negative B divided by 2A, okay? Guess what? Oh my gosh, it's the H value. Yes, your axis of symmetry is whatever your H is, okay? Then you're going to determine your y-intercept. Your y-intercept is always your C term in standard form. So your y-intercept is always going to be your C. Because it's saying if I plug in 0, what's the last man standing? C. And then your x-intercepts. So 2.2 was all about finding x-intercepts, whether it was through factoring, grouping, completing the square, or the quadratic formula. In 2.2, we practice finding the x-intercepts, right? So whatever method you choose to do in step 4 to find the x-intercepts is up to you, okay? You can quickly determine what type of x-intercept you're going to have if you are using the quadratic formula and you're looking at your, what's called your discriminant. We're going to talk about a little bit more in a bit. But the b squared minus 4ac lets you know whether you're going to have 2 real solutions, 1 real solution, or no real solution, okay? If I have 2 real solutions, that means that my discriminant is greater than 0. So my graph is going to cross the x-axis at 2 locations. Make sense? If my discriminant equals 0, that means that my graph is going to sit on the x-axis at 1 location. And if my discriminant is less than 0, is negative, that means that there are no x-intercepts. And the reason why there's no x-intercepts is because it's just floating out here in space. Okay. Last, you're going to find all your points. You're going to graph what you have, your y-intercept, your x-intercept, your absolute symmetry, and you're going to put it on the graph and draw the graph. And ta-da, you're a human calculator. Okay, ready? We're going to go through these steps. Remember how I told you there's more details about the discriminant? The discriminant comes from your quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Hey, okay, I would bet money that on the PSAT that you took yesterday, there was at least one problem where you had the opportunity or the option to use the quadratic formula.
There was.
I bet I would bet money it's on every single PSAT and SAT test. Okay. All right. So I've been saying it for 2 decades now. You just gotta accept it into your memory and into your hearts. Okay, there we go. All right. Now, your A again, just prettier pictures of what I tried to draw. Again, if your discriminant is positive, you're going to cross the x-axis twice. If your discriminant equals 0, you're going to touch the x-axis. And if your discriminant is less than 0, you're going to be floating. Did you see that? Yeah. So those are the prettier pictures of 2, 1, and no x-intercept. All right. Let's put this to use. So on your thingy, you're gonna write down the function f of x equals 2x squared minus 4x plus 2. So this is what we're gonna follow the 6 steps with. So right underneath, you should have a table, graph, all that good stuff, right? You all see it? Okay. The first thing we're gonna do is find your x-intercept, your y-intercept, and your vertex. Of these 3 things to do, your vertex is gonna always, your y-intercept is gonna always be the easiest to find. Okay. Why is your y-intercept gonna be the easiest to find? It's just the c. And what is our c? 2. Positive 2. Bam. Found the y-intercept. So I can go to my graph, go to 0, 2, and plot it. Bam. How do we feel about finding the y-intercept? Doable, right? The second thing we're gonna do, the second easy thing to do is to find your vertex. Okay. Your vertex means that you're looking for your h comma your k. So if I'm looking for h and k, you got to find your h first, and h equals negative b divided by 2a, right? Do I know what b is and a? Yes. We're going to plug them in. So we have negative 4 divided by 2 times 2. What is my h? 1. A negative times a negative is a positive. So it's a positive 1. So we have h equals 1. To find k, we have 2 options. We either can plug in or memorize the k formula. In this case, it's a 1. Can we plug in 1? Are you comfortable plugging in for 1? So k, I know. 1 times things, where do they learn that at? So we have 2 times 1 squared minus 4 times 1 plus 2. What do I get? What's 2 minus 4? What's negative 2 plus 2?
Uh-oh. Wow. Yeah, I just can't simplify it myself. Yeah, look at that equation.
Okay, so remember you solve from left to right. So if you didn't solve for left to right, would you have gotten to 0?
No.
When you're adding, subtracting, we go left to right. So we have 2 times 1 is 2. Negative 4 times 1 is negative 4. And plus 2. Left to right, 2 minus 4 equals negative 2 plus 2. And that's how you end up with 0. If you did not go left to right, you probably would have written, I don't know. I've seen people make 4. And I'm like, how'd you get 4? The 2's go away. Oh, okay. Cool. Just makeup math. All right. So now I know that my vertex is where? I have H and K, so 1, 0. Is that what I heard? I heard 1, 0. All right. So now we have our vertex at 1, 0. Oh my gosh, that means that's also a what? It's an x-intercept. You don't say. That's crazy, mind blown. Okay. Now, quick note here. Notice how it's 1, 0. When I'm just looking at this graph, is there any possible way that it's going to touch the x-axis again? No, there isn't. And I can verify that by just doing the discriminant for x equals, if I did negative b, I can't even write, guys. X equals b squared minus 4ac. And the reason why it's only going to be 1 is if I plug these in, b squared is negative 4 squared is going to give me 16. And what's 4 times 2 times 2? That's also 16, right? Yeah. And this equals 0. And if our discriminant is 0, how many times am I going to cross the x-axis? 1. One time, right? Which is why this is where it stops at, okay? So now I'm going to use my axis of symmetry. And axis of symmetry acts as my line of reflection, right? So I reflect from here to here. And I'm going to pretend that this is the best parabola you've ever seen. Okay. So now, and now you can analyze. What's the domain?
1, 0.
All real numbers. From negative infinity to positive infinity. What's my range? 0 to infinity, or y is greater than or equal to 0. I don't know. Okay. And then where is the function increasing? So we increase from 0 to positive infinity. And where do we decrease? Negative infinity to 0. Now, was that terrible? Oh my gosh. Y'all are so dramatic. So for the remainder of the period, I want you to work in your groups on the student practice on the back. Until the bell. And we will check tomorrow how you did. Okay? So you're doing this one on the back of your paper. Your equation is f of x equals 2x squared plus 4x minus 1. Write it down. What is it? F of x equals 2x squared plus 4x minus 1. Got it? Did we write it down? All right. I'm not closing it.